The mass m grams of a radioactive substance T years after first being observed is modelled by the equation m equals 25e to the power of minus 0.05 t. According to the model, part A is asking us to find the mass of the radioactive substance 6 months after it was first observed. So the first thing we need to note for this question is that in the information given, we're told that the units of t is years, and in the question, we're given a time frame that's in months, 6 months. And we know that 6 months is half a year because there are 12 months in a year. So that's the first thing we need to notice, is we need to convert between months and years to say that 6 months is 0.5 years. So now all we need to do is, if we look into this, we look into the equation up here. To find m, the mass of a radioactive substance, we just need a time. We just need to substitute in a value of t. So if we say this value of t is 0.5 years, the equation, according to the model, the equation will give us the mass of the radioactive substance after 0.5 years. So if we substitute in t equals 0.5 into our equation, we get that m equals 25e to the power of minus 0.05 multiplied by 0.5. And if we put this into our calculator, we get that the value of m to 3 significant figures is 24.4, and then, because in the question we're told that it's m grams, we know it's 24.4 grams. And that's our answer. So the 2 marks for this question come from, our first mark is for substituting in t equals 0.5 years, and that's a method mark. And then we get an answer mark for actually getting that m is equal to 24.4 grams. So part B is asking us to show that dm by dt is equal to km, where k is a constant to be found. So the first thing we need to do is remember the general rule for differentiating exponential equations, because this is what this is, and we know that because of the e to the power of something. So if we say that y is equal to e to the power of kx, just as a general exponential function, the way we find dy by dx is we take the derivative of the exponent, which is, in this case, the power, so kx is the exponent in this case, and we take the derivative of that, which is k, and we multiply it, we bring it to the front, we multiply it by the e to the power of kx. So if the derivative of kx is k, we do k multiplied by e to the power of kx, that bit stays the same, and that's how we differentiate an exponential function. So if we put this into the context of the question, the numbers we've been given, if m is equal to 25e to the power of minus 0.05 t, using the same principle, we take the derivative of the exponent, the derivative of minus 0.05 t, which happens to be minus 0.05, and we do minus 0.05 multiplied by, and then the original equation, so 25e to the power of minus 0.05 t. Now you'll see in the question that we were asked to give it in the form km, and if we know that m is equal to 25e to the power of minus 0.05 t, we can see that this is actually found here. So we have an m, and therefore we can write this as minus 0.05 multiplied by m. And you can see this is pretty much the same form that we've been asked to show it in, except we now know that k is minus 0.05. And this gets us all 2 marks. We get a method mark for just showing that we know how to differentiate the function, we know how to differentiate m. So that would get us our first mark. And then we finally get an answer mark for showing that k is therefore minus 0.05, or just writing it in the form km, that implies that k is minus 0.05.